Okay, here's our postage stamps, the one for Leibniz, the one for Newton, the two contemporaries that invented calculus independently. Before that, I have a postage stamp for Descartes, and Descartes lived a little bit before these two, and Descartes, the person that invented the rectangular coordinate system. And that rectangular coordinate system is the thing that gives us a connection between algebra and geometry, and it's called analytic geometry. But that had to be invented first before Leibniz and Newton could invent calculus. So as far as the sequence of events that happened that created calculus, you have to include Descartes up here. Okay, so in this section, we're going to be looking at implicit differentiation. So I really like implicit differentiation. So if I say y is equal to f of x, and that's x cubed minus 2x, I see that y is given explicitly in terms of x. That is, y is just some function of x. All I see on this side are x's. So y is given explicitly in terms of x. If I have an equation like this, x squared plus y squared equals 9, y is given implicitly in terms of x, because to find out what y would be explicitly in terms of x, I would have to solve this equation here for y. So I'd rather not have to do that every time that I ran across something like this, so I need some rules for how to differentiate implicitly, that is, when y is not given explicitly in terms of x, but is implied by the equation that y would be given explicitly in terms of x. So it turns out to be really easy to do implicit differentiation. You just start on the left and go left to right and differentiate everything you see with respect to whatever variable is in question. You'll see when we get to this lesson.